Hey, welcome back, everybody. My name is GHS InfoSec, and we are back on TryHackMe.com looking at the Advent of Cyber 3 challenges. Today, we're going to be looking at day 9. It is actually December the 10th. I'm a day late and $1 short on getting this out. I've been keeping up with the challenges. I just haven't been able to make any videos. But anyway, we're over here at the TryHackMe.com/Christmas page. You still got time to join. You've got all the way up until December 25th. It's totally free. It's totally fun. I highly recommend you do it. So anyway, with that out of the way, let's go ahead and get started. All right, so I'm over here at the Advent of Cyber page, and I'm looking at task number 14, day 9. This is a networking challenge, and it's titled, Where is all this data going? And we have some task files to download. I've already done that. So make sure you have those downloaded, and it says, McSkitty recently found out that a large amount of traffic is entering one system on the network. Use your traffic analysis skills to determine what kind of activities Grinch enterprises are performing. In this task, we will walk you through the required skills and knowledge to perform a basic packet analysis using Wireshark. Now, Wireshark is a really cool tool. It gives you like deep byte level access into each packet that you capture that traverses the network, on whichever interface you happen to be capturing on. And there's also a command line version called T-Shark, which I would love to showcase for this video, but I'm going to stick with Wireshark because it's a lot more simple, especially if you don't have any experience with that. And T-Shark can be a little bit complicated, but you can get some really good insights with T-Shark too. So at some point on the channel, I plan on releasing some videos on both Wireshark and T-Shark, so be sure to like and subscribe and stay tuned to look out for that content. Anyway, moving on. It says packet analysis is a technique used to capture and intercept network traffic that passes a computer's network interfaces. Packet analysis may also be called with different terms such as a packet sniffer, packet analyzer, protocol analyzer, or network analyzer. All these things apply. That is absolutely true. As a cybersecurity individual, gaining packet analysis skills is an important requirement for network troubleshooting and communication protocol analysis. Using network analysis tools such as Wireshark, it captures network packets in real time and displays them in human-readable format. It provides many advanced features, including the live capture and offline analysis. This task covers the packet analysis steps in detail using Wireshark to analyze various protocols. These are unencrypted protocols such as HTTP, DNS, and FTP. And looking at the required skills and knowledge, we're assuming that the user has basic background skills to complete this task, requires theoretical and practical knowledge, including basic networking concepts, TCP/IP stack, OSI model, and the TCP handshake. This applies not only to packet analysis, but also to most other topics we'll deal with in cybersecurity. A great resource for this is the SANS Institute Internet Storm Center. I believe it is ISC. Look at the old Google machine here, ISC2 maybe. No, that is actually for certifications. Let me look up Internet Storm Center. If I can spell. SANS Internet Storm Center. There we go. They got a lot of great resources on here, including a TCP and UDP header cheat sheet for like the TCP/IP stack and TCP dump. It's like a pocket reference guide. I'll leave a link to that in the description. It's a really great resource if you don't have any experience with that, but I highly recommend you check that out, and that'll be in the description below. All right, so packet analysis tools. There are many tools using network traffic analysis and network sniffing. Each of these tools provides a different way to capture traffic or dissect it. Some offer ways to copy and capture, while others just read and ingest using different interfaces. In this room, we will explore Wireshark, and it says here, keep in mind that these tools require administrator privileges, and that is true. What is Wireshark? It is pre-installed on the THM attack box, and you can just launch the attack box by using the Start Attack Box button and opening Wireshark. I actually have that downloaded on my machine. If you're running Linux, you can use your package manager to install Wireshark. And if you are using Windows, you can just go to Google and look up Wireshark, and you can download the executable there. And they actually have a link to that, so that's perfect. So here is the page to download Wireshark. Make sure you choose the correct installer for your architecture. If you have a 32-bit or 64-bit, does anybody even use 32-bit anymore? Let's be for real. All right, so let's head back over here. It says for this task, we have prepared a PCAP file to download and follow the instructions and apply the required packet analysis skills using different scenarios. If you're using the attack box, you don't need to download the files, blah, blah, blah. And the file is aoc3.pcap. it is in the following location on the attack box. So if you're using the attack box, that's where you'll find it. We can run Wireshark and import the provided PCAP as follows. So I am going to switch over to another tag here, and I'm just going to launch Wireshark real quick. Widow. How about sudo? How about sudo? How about, wow, I am struggling today. Sudo Wireshark. Wireshark. I can't believe I just typed that. All right, so let's launch Wireshark. We'll hide that. I'm going to go ahead and open that PCAP file. And for me, it is in my CTF directory. Here we go. And THM, AOC3, day 9. AOC3.pcap. Let's open this guy up. And you can see we have a lot of packets here. We start off with an ICMP v6. I've actually never seen that in the real world, so that's pretty cool. And then we've got all kinds of HTTP TCP and SSL data. By default, Wireshark is going to try and decode the protocol. You can change your preferences to just show the port instead of the protocol, but we'll just leave it alone for now. We won't worry about that. We'll save that for another video. But we can let's go ahead and let's launch a terminal. And I'm going to CD into that directory, day 9. And there's another tool you can install called capinfos, and you can run that on your PCAP file and get some information about it. So we can see that there are, this is the length of the capture, there's 5,208 packets. This is a PCAP file, and it's about 6 megs or so, and it also shows the packet count up here. So you can get a little bit of information on that with the capinfos. I'm just going to move this to another tag and get that out of the way so we can keep the Wireshark window full screen. Let's go back over here and see what we are going to do. All right, it says the Wireshark interface has 5 major components. The command menus are standard pull-down menus at the top of the window. Of interest to us are the file and capture menus. The file menu allows you to save captured packet data or open a file containing previously captured packet data and exit the application, which we already looked at. And then we have the display filter, which for us is going to be right here. It's going to look a little different. I have a dark theme set up on my machine here. And it says display section is where we can specify rules to find certain packets. The listing of captured packets shows all sent and received network packets. This section includes important fields that are used in the filter section, such as source and destination IP address, protocols, and information. Next are the details of a selected packet header. This section shows details about selected packets, shows all headers, including all TCP layers information. Finally, the packet content, which shows the packet content in a hexadecimal and ASCII format. So here we have the packet details where you could see we have a frame line here, and it starts at layer 2. So we have our Ethernet header here, and then our IPv6 header, and then the ICMP header for ICMP v6. And then down here, you see the actual content of the packets. These are the actual bytes. Looking at the resource for the TCP dump and TCP IP pocket reference or cheat sheet, you actually, if you take the time to learn how to read the headers, you can actually read these headers and see, what kind of stuff is here. And then over here is the ASCII representation of what is actually in those bytes, how it actually gets interpreted. So this is about as low of a level as you can get without going to the actual binary data. It's very cool. And I'll also leave a link to some Wireshark filter references. That way you can learn how to filter on certain things like TCP or HTTP and things like that. And moving on, we are looking at the filter section. It uses the Berkeley packet filter, or BPF for short syntax. It's used in packet analyzers to filter certain packets pre-capture. Filtering packets is beneficial when locating information within a packet capture process. Wireshark syntax is the primary method we will use in this room to locate certain protocols and information. And they've included some examples of some display filters. So in this example here, we're looking for the IP address of 172.21.2.116. And this is how you would actually use that filter. You would say ip.addr for IP address equals, and you use equals to say that it equals 172.21.2.116. And you can see that the display window here shows only those packets where that IP address is present. They could be the source or the destination, but this is actually what you would get in order to filter out all of this mess. You know, instead of seeing everything, you're just going to filter on those packets that contain or that match that filter. So as I just said, we can see that we're able to show only the packets that we need. Next, we can also specify certain protocols such as HTTP, showing all packets for this protocol. We can also specify a domain name to narrow down the search. And the following example shows that we are looking for HTTP packets that have the google.com domain name with the filter HTTP contains google.com, and they have an example of that here. Next, we can also look at a specific port. Let's try to filter and list packets for the remote desktop protocol. We can do that by typing tcp.port or tcp.port equals 3389. That is the default port for RDP on Windows systems. And you can see that example here. However, assume that you are monitoring the network traffic and you want to exclude RDP packets. In this case, we can use the not Wireshark rule as shown below. So here we say not tcp.port equals 3389. I'm going to click on that. Well, that didn't make it any bigger, but just know that if you're going to exclude something, you would put what you're excluding after the not filter. Next, we'll perform a packet analysis technique using various protocols, including HTTP, FTP, and DNS. Note, it says make sure to open the Wireshark tool and the AOC.3 PCAP. It's important to follow up with this content. So we're going to be looking at an HTTP GET request. And just to make sure I'm not missing anything here, I'm going to go ahead and look at the first question just to see what we're going to get. So yeah, this is actually going to be the first question. And it says, which directory is found on the server? So we're going to come back up here. And let's read through here just to be sure we are following this along. So it says we're going to be looking at HTTP traffic. Once we open the PCAP using Wireshark, it will show a lot of network traffic since we connect using the RDP protocol, making our work harder. However, we'll be using a filter to focus on web requests only. In this case, we're only dealing with HTTP. Therefore, we can use Wireshark rules to make it easier. We can apply the following rule to only show the HTTP traffic. Following figure shows all HTTP traffic that has been sent to and from the web server. In the first packet, we can see the web request is sent from our machine, which is 192.168.100.95 in this example. It is sent to the web server, which is also our machine. In the information section, we see that we also sent a GET request. You can see in that first line here, this highlighted packet, we're getting get/admin and then the protocol HTTP 1/1.1. GET request trying to get admin content. On the next packet, the server will reply with the code 404, which means it is not found. So it's important to understand the HTTP return codes. 400 codes are typically going to be a client-side code to let you know that, hey, that doesn't exist and the error is on your part. If it's a 500 code, that means there's a server error. You should look those up on your own at some other time. And suppose we need more details on a particular packet. In this case, we can expand using the caret sign, the HTTP transfer protocol, or excuse me, the hypertext transfer protocol subtree for more details about the sender request. So that would be here in this details pane. So we're going to expand this HTTP layer section here to see a little bit more information. You can see details about the send request and the IP address, the user agent, and other stuff. And that stuff will also show up down here in the packets, but if you want to break it down, just as a quick example, we'll just take this packet, we'll expand it. So you get the details, like the actual packet details down here, but a little more information. It gets broken out here. It shows the flags that were sent. This was an acknowledgement flag, and it shows you that bit is set and so forth. So let's go back over here. We can specify the HTTP method. In this case, we could show all the GET requests using the following filter. http.request.method equals GET. Keep following the GET request and answer the question in this task. So we're going to go down here to the first question and look at this again, and we're going to use this filter, http.request.method equals GET. So let's head back over to Wireshark and let's type that into our filter. Let's make this just a little bit bigger. So http.request.method equals get, and we're going to hit enter on that. And we can see the first packet that shows up here is a GET request for the login page. So let's go back over here, and our answer is going to be login. All right, and what is the username and password used in the login page in the HTTP2 post section? So in this example here, we actually have to use the post method. So let's go back over to our page, and we're going to say post. So the first thing we get here is a post, and in this post request, let me collapse this. We're going to expand this here, and the user agent is TryHackMe, and here is a flag, which will probably come in a later question. But we are looking for a username and a password. So we're probably going to find that in the form, which the username here is going to be McSkitty, and the password is Christmas 2021 ! So we're going to say McSkitty and Christmas 2021, bang. All right, and what is the agent's username that is, or excuse me, what is the user agent's name that has been sent in the post section? And we saw that was our flag there. So let's get that value. And you can see it highlights it down here in the details whenever you select an element of this thing here. So you can right click here, go to copy, and go to value, because this is like a key value pair, the key being the user agent and the value being TryHackMe user agent, blah, blah, blah. So let's paste that in and submit that. And just to make sure we're not missing anything, I'm going to go back through. You'll want to go through and read through this information here. You can also do, okay, so they're recommending following the TCP stream. So instead of actually going through and doing all this here manually, what you can do is, and this is a neat trick, I didn't realize they would show this, you can follow the TCP stream or the HTTP stream, and what that will do is bring up another window. As you can see here, it gives you all these details for this particular stream that we filtered on in this request. So you can see the post information, anything highlighted in red is sent by you, by the user, and anything in blue is what's returned by the server. So we can see the user agent here, which is TryHackMe user agent in our flag, and also the username and password that is sent to that application. Now it is URL encoded. You can see the %21 here. So unless you decode that, you're not going to actually know that that is the exclamation point, but that's important because you have to understand how to decode URLs. You can Google URL decoder or encoder online, and you can find that. I believe CyberChef has that as well. But this is just a quick way to get a fast view of whatever you're looking at to follow the TCP stream and see that communication between the client and the server. All right, so let's head back over here to the questions. And I would encourage you, once again, to read through this stuff here. For the most part, like all of these are going to behave the same way. It's just going to give you a little more information on exactly what you're trying to do. And we'll walk through some of that as well. So it shows you here, like I mentioned before, on how to follow streams. So now in the DNS section, there is a text DNS entry. What is the flag and the message of that DNS query? So let's go back over here and let's close this window and let's filter for DNS. And we can simply just type DNS. And let's go ahead and right click and follow the UDP stream. That's not going to be it. Down here we have a stream number, and there's 86 total streams. We can also just cycle through these streams by clicking the arrows. And so instead of going through all of this, let's go ahead, let's close this out, and let's do dns.txt. Since we're looking for a text record, we should find something here. And if we look at the response, it's not in the response. Let's check the UDP protocol here. Let's follow this stream. We can see here we get the response from the server. AOC is awesome, and here is our flag. So let's copy this, and we'll paste this in. In the FTP section, what is the FTP login and password? And this is important. I meant to mention this earlier. Anytime you're using an unencrypted protocol, you want to be sure, well, you are going to be able to see any posted information. So any usernames or passwords that are submitted via FTP or via HTTP, which are unencrypted, you're going to be able to sniff those passwords. So we can see here, we actually see the FTP response from the server back to our host machine, and then the request, we're sending the user information TryHack FTP, and the password is TryHackMe in elite speak or in some type of secure password format. So our question is looking for the FTP login password. So let's go back over here and we can just copy this value. So right click and copy the value. And we'll paste that in and make sure to remove the trailing backslash, and actually let's remove pass as well. Okay, in the FTP section, what is the FTP command used to upload the secret.txt file? All right, so we're going to head back over here and we're going to look up, there's our store request, and it is for secret.txt. And so if we click on this file here, the request command is store. I don't think that's actually what we're looking for. Oh yeah, it is. Okay. STOR. A lot of times when you're using FTP, in order to put something on an FTP server or upload it, you would use the put command. So I was a little confused about that, but that's the method that the FTP is using in that case. In the FTP section, what is the content of the secret.txt file? And you can see we're using the filter FTP-data. So let's go back over here and we will say FTP-data. And we can see we have the contents of this file here. And if we follow that stream, we can see the contents of this file. And does it want all of that stuff? No, it just wants this part here. So let's copy this. It is 123 /321. And we will paste that in. And that is it. So that's that challenge done. That is day 9, Wireshark in the books. Thank you guys so much for watching. I hope you learned something. It's been a little while since I've used Wireshark, but I'm still very familiar with it. There's a lot of neat features to it, and I highly encourage you to download it if you hadn't already and go through this challenge. There are plenty of examples of packet capture files that you can go through and resources online to learn how to use Wireshark or T-Shark and analyze network traffic. Is very, very important skill to have, especially in cybersecurity. So I apologize if this seemed a little bit discombobulated. I didn't completely follow the script like I did in the last 2 videos, but I really do thank you for watching. Thank you to all of my recent subscribers. I have more than doubled my subscriber count. I'm only up to 30 so far, but I really appreciate the support. I appreciate the love and the subscriptions and the likes and all that. Please continue to do so. If you're new to the channel, thank you for coming by. Please subscribe. Please like the video. Share this with anyone you think may be interested in this kind of content. And thank you so much for watching.